So slide 4, okay, looks a little bit more complicated than it actually is. When you're writing complex numbers, remember you got two pieces. You got your real part and you got your imaginary part. So what I'm going to do here is I'm taking each fraction here of 5 plus or minus 3i over 2, and I'm splitting it into the real part into the imaginary part. And the way that works is that my denominator of 2 just gets assigned to both the real and the imaginary part. So it becomes 5 over 2. Now for the plus or minus, you could continue with the way we've been doing it, or you can actually just copy and paste it in like that. So it would be 5 over 2 plus or minus 3i divided by 2. So that the denominator of 2 just got split up between the two terms. And that is how we get it into complex form, into the two terms. Go ahead and pause this video and finish doing the rest on your own. All right, let's take a look at the answers. So we should be splitting up the real and the imaginary. So 4 divided by 4 plus or minus 12i divided by 4. Now let's see if you picked up on the fact that you could simplify this further. How can you simplify it further? Well, 4 divided by 4 is 1. 12i divided by 4 is 3i, because 4 goes into 12 3 times. So 1 plus or minus 3i would actually be the simplified complex number. We can only simplify like this when they come out to be whole numbers, like 1 and 3. In the first problem, 5 over 2 would be 2.5. That's not a whole number. 3 over 2 would be 1.5. That's not a whole number. So we're just going to leave them in fractions then for number 1. But anytime you can get it down into whole numbers, like in number 2, we want to make that happen. All right, on to number 3. 3 divided by 2 plus or minus. And because we are now wiser, we can no longer leave this as the square root of -9. We're going to change it, right, to the square root of 9, square root of -1. And using what we know about imaginary numbers, we know that the square root of -1 is I. And we know that the square root of 9 is 3. So your final answer here is 3 divided by 2 plus or minus 3i divided by 2. And lastly, number 4. 7 divided by 3 plus or minus. And again, right, alarm bells are going off. We have a negative under the square root. We can't have that. So we're going to rewrite it as square root of 30i. Square root of 30 doesn't simplify into a number into a whole number like square root of 9 simplified down to 3. So we're just going to leave it as the square root of 30, and that's my final answer there for number 4. So if we look at these answers where we have 7 plus or minus the square root of -30 all over 3. Ask yourself, the format of that answer, what does it remind you of? If you said quadratic formula, you would be correct. We have been solving using the quadratic formula, and anytime we got a negative under the square root, we would always say no real solution. But we now know how to find that solution, and that solution is this complex number. So you're going to go ahead and solve slide 5 by using the quadratic formula. Go ahead and pause the video and do so. All right, so let's go ahead to the next slide and see how you did. You should have ended up with the final answer of x equals 5 over 6 plus or minus the square root of 35i divided by 6. That would be your final complex solution. A couple of things to be aware of is when you put a -5 in for b, remember minus a negative is going to make this a +5. When you get to this point right here, we're not done because I have a negative and I only have one term. So I split into the two terms. I take my negative out and replace it with my imaginary number, and I am done. You can go ahead now and try slide 7. So go ahead and pause the video and check in when you're done. All right, let's see how we did. Now, this one may have stumped you because you were expecting an imaginary number and you didn't. And that was on purpose. Just because we're moving into imaginary numbers doesn't mean you're always going to get imaginary numbers. You may still end up getting positive values under the square root. And when that's the case, there's no need for imaginary numbers. So we only need them when we have negative square roots. So 10 plus or minus the square root of 140 over 10, that would be your final answer. Now, what I want you to do on slide 9 is I want you to compare these two problems. These are the same two problems that you just did. And if you recall, right, we got an imaginary number the first time around and a real number the second time around. Look at the problems, look at your functions, and compare the values and make observation about what leads to imaginary numbers in the solution. Okay, why did I get an imaginary number in the first one and a real number in the second one? Go ahead and pause the video and do so. All right, so let's take a look at why this happens. Well, as we know, right, everything's going to happen underneath that square root. If there's not a negative under that square root, we're not going to get imaginary. So there's something that's going on underneath that square root. And we call the value under the square root the discriminant. Anytime the discriminant is negative, that's going to lead to an imaginary number in the answer. Negative means that b squared minus 4ac is less than 0. Right, -1, -2, all those values less than 0. So, how can I look at functions like we have below and determine which one's going to give me it should say not complex truth, it should say imaginary or a non-real solution? Well, how do we know? Well, anytime b squared, so this term right here, anytime that's smaller or less than your 4ac value, you're going to end up with a negative underneath the square root. Right? If b squared comes out to be 1 and 4ac comes out to be 5, well, 1 minus 5 would be -4. We'd end up with a negative underneath the square root. And again, that happens anytime your 4ac value is going to be bigger than your b squared value. So compare these three functions, okay, using what we just learned, which one is going to have a non-real solution, or which one's going to end up with an imaginary number in the solution. Go ahead and try, pause the video, and then check back in. Okay, after going through, you should have found that this last one right here is the one that's going to have an imaginary number. We are going to get 5 squared, which is 25, and then 4ac, which is going to be 4 times a, which is 4, times c, which is 10, which is going to give me 160. So 160 is going to be greater than 25, so it's the last function that's going to end up with a non-real or an imaginary value in its solution.